Hi, class. We've talked about a lot of things that help us understand the Earth's past, whether it's rocks or fossils. And now, what we need to do is try to put all of that together so we can understand the organization of what's happened before today. If I ask you things like, when did the dinosaurs die? When did Pangea break up? When was the last ice age? When did the Rocky Mountains form? When did oxygen form in the atmosphere? When did oceans form on this planet? Your answer to most of those is going to be a really long time ago. And it's hard for us to put things in order when that's our only defining trait, a really long time ago. So, what the geologic time scale allows us to do is it allows us to organize things and give us a system of organization to be able to say this happened before that and use terms to be able to do that. So it's our calendar of events that divides up the Earth's past. And you know that a calendar is designed to organize what's going on in a week, what's going on in a month, what's going on in a year, and the same idea with the Earth's past. You're going to be taking notes on this note sheet. So please make sure that you have this out. We're going to fill in this whole thing today. And if you need to stop or pause or back up, which you will because the first answer is already on the note sheet that I gave you, and to get that information. Okay, so what are some basics about geologic time? The first thing you need to know, using radioactive decay, we're able to determine that the Earth is about 4.6 billion years old. We've got lots of old rocks. Some are in Russia, some are in Australia, some are actually in Montana, some of the oldest rocks in the world, and we've age dated them to 4.6 billion years old as the age of the Earth. So that's how much time we have to divide up in our really long time period for how the Earth is existed. So using the geologic timescale, what that allows us to do is it allows us to organize those events and understand the length of processes. So I already talked about the order of events, but length of processes works like this. So we know there was a time about 55 million years ago when it was much hotter on the Earth than it is today, which is something we can compare to what's going on today. However, what we know is it took about 50,000 years for it to get that warm and almost as long or longer for it to cool down from that. And what we're looking at today is the same temperature change here on Earth is happening in a scale of like 100 years or 1,000 years. So it's much, much faster what's happening today than what we've seen in the past, even though there have been times that are warmer. So we understand the length of processes. We're going to use evidence from all these things we've talked about already, which is fossils and rock layers, to help us understand what was going on in the past. So it tells us about what past life forms there are, what past environments there are from rocks, and then we can help organize and determine what happened first and second and third. So rocks are going to show us the major geologic events, the breakup of supercontinents like Pangea, and when mountains formed, where continents were, things like ice ages, those are preserved in the rock layers. Fossils are going to show us the appearance of new species, extinctions, and how the diversity of life changed over time. So did we have all the species that we have today all at once when the Earth got here, or has that changed over time to where we've increased the diversity of species and the number of species over time as life has developed? That's what the geologic timescale can help us understand that. So a little bit of basics about the geologic timescale. We divide it up into different segments, and we do this in a similar way like you would divide up a calendar. So a calendar is divided up into days and divided up into weeks and months. And also, if you want to get even more specific, you can divide it within hours within a day. And the same thing we do with geologic time. So here's a simplified geologic time scale. So 4.6 billion years ago is the start of the Earth, and present is today. And you can see some divisions in here. So the primary division that we use is what's called an eon. These are the longest ones. There's 4 of them that happen between about 4.6 and about 0.6 billion years ago. So most of the Earth's time period is in these 3, the Hadean, the Archean, and the Proterozoic. And then the 4th one is the Phanerozoic. And then we can divide those up into what we call eras. There's also 4 eras. We create those divisions generally on major geologic events, huge changes, and mass extinctions. Those allow us to say, okay, this time period has ended, this era has ended, and this next one has started because we have the appearance of this brand new species or the disappearance of this dominant species, and that allows us to create those divisions. And then if we want to divide further within that, and we need to, especially within the Phanerozoic, we need to divide into what are called periods, and these are in major evolutionary changes in life forms and expansions in species. So this would be things like the appearance of the first fish, etc. So let's give you an idea of some things that have happened in the Earth's past here. Just real quick overview. So if we look at this, the Earth formed 4.6 billion years ago. Hundreds of millions of years after that, the oceans formed. Roughly around 4 billion years ago, we think the first life appeared on this planet. As far as the fossil record shows, this is a bacteria, so single-celled organisms, very, very simple. Our oxygen atmosphere formed roughly in the 3 billion years ago range, and so did the appearance of molecular organisms. These are multiple cells stuck together in a simple format like an algae. Then plants appear much later. So not even a billion years ago do we have plants. It was more recent than that. Multicellular organisms. So these are creatures that have more than one cell within them that each do a different job, but they work together to support the organism. There's a creature called an Ediacaran. That would be an example of that. We get the first fish at about 500 million years ago. And then dinosaurs at roughly 150 million years ago, 200 million years ago. And then our humans appear really, really late in the whole scheme of the Earth in what we call the Cenozoic time period, so about 4 million years ago. If you stretch out your arms, and the length of your arms is the whole geologic time period, humans appeared like on the end of your fingernail. That's how recent we are. We haven't been around that long, okay? All right, so some more details about the geologic timescale, some more specifics. If we talk about the eons first, this is where there really wasn't a lot of life forms, and the ones that were there were pretty simple, mostly bacteria, single-celled organisms. The Hadean time period, like Hades, it was hellish, so hot, volcanic, and life may have formed at the end of this as the Earth was starting to solidify in some places, changing from a lava world to a rock world. In the Archean, this is the most simplest life forms here. This is bacteria. This is where photosynthesis finally occurred and where oxygen was introduced into the atmosphere because of photosynthetic organisms. These are the type of organisms that we find like in hot springs at Yellowstone National Park. And then the Proterozoic, this is where life starts to diversify some, but all life is in the ocean at this point. It's really simple. It's not complex. It's these stromatolites that we talked about when we were looking at fossils. So algae mats, not very complex stuff, but doing photosynthesis, changing the Earth's atmosphere. So we're going to get more detail. We're going to look at periods within those eras. Life gets much more complex in here, so we have a lot of things that we can create divisions on. The first is the Cambrian. This is where we have a huge explosion in diversity of animals in the ocean, and we also get the first fish during this time period. In the Silurian, we get the first plants and animals on land. This is crazy to think about that prior to about 500 million years ago, there wasn't anything on the land at all. That's wild. In the Jurassic, of course, we have dinosaurs. We also have the first mammals and the first birds appearing in the Jurassic. In the Cretaceous, we have the end of the dinosaurs, which is a great place to cause a division, and also flowering plants evolved. This flowering plants is important because flowering plants also includes things like fruit. In the Neogene, so we're getting very current now, we get grass that forms, and grass is a great evolutionary adaptation of plants that can be basically eaten by other animals and continue to grow back, and also the first hominids. Hominids are the early ancestors of humans, so this is where humans appeared. And in the Quaternary, which is some would argue that we're still in the Quaternary or we've moved into a new period, but this is where humans are the dominant species and animals have been domesticated. There was also an ice age during this time period. And so that will complete your note sheet. What you're going to do next is a worksheet using some pages from the textbook, which are scanned onto the Google Classroom to learn a little more detail about our geologic timescale in the Earth's past.